Alright, so working on a 1984 Mercedes-Benz 380 SL with the Bosch CIS system. I believe this is a K Jetronic with feedback. Of course, you can see the frequency valve here. It's got the lambda sensor, otherwise basically oxygen sensor that the computer uses to control the frequency of that. That just opens a bypass circuit that basically comes through the first initial pressure dampener / regulator, comes through and then basically bleeds off to the return line. Watch out for restricted return line on these. Could cause some pressure problems with both system pressure and control pressure, and you got to remember that these systems are all based on a balance of pressures. You got a series of differential pressure regulators inside here. These are the basically adjusting ports for each different injector port or independent, differential pressure regulator that runs that respective injector. And the top bolt here is just basically a dust cap. This one came in with, of course, a telltale sign of one dust cap having been removed and tampering that basically can throw the whole system out of whack. So what we did was took the system off, and of course, being in 1984. This one had sat for a while, collected a lot of goo, and basically we're going through to do a flow balance test. Found quite a big difference, big variation across the cylinders. What you want to do is open this airflow plate, and of course the way this system works is airflow plate is connected via a lever to a plunger in the middle of this fuel distributor. This plunger, as it moves up and down according to the depth of movement of air drawing across this plate and forcing this thing down, will open up slits, and there's a independent slit for each one of these injectors, and as that plunger comes down, more of the slit will be exposed and more pressure, more fuel will actually flow to that injector. Aside from that, these injectors, there's nothing more to these injectors than just a spring-loaded little pop-up valve. And because of that spring and the seat there, when they flow, they will give a little buzz, hum, or kind of a whine noise to them. What can gum up in them? What we're finding on this one is most likely the slits in the fuel distributor, just because as we're running, circulating, a gallon of fluid with a good, high-quality, off-the-shelf cleaner. In this case, we're using the BG products, Ken's and Leslie's 44K. We've had good luck with that and really trust that product. And we're circulating that through and just running test after test and all different depths of simulated airflow, basically depths of movement of the plate. We typically want to take your measurements at about half of total travel and about 1/4 inch of travel. And that seems to make sure that you've covered majority of the most common operating ranges. And then when you're done, you want to take your graduated cylinders and make sure that at those different levels that you have no more discrepancy volume from one to the next, more than 10%. Kind of similar to a compression test. So what we've got in our setup here is, of course, we're tying in line with control pressure. So we're coming out of here, breaking this line and putting a valve loop in line. You want to make sure that you have the valve downstream so that you can block that off and measure system pressure. Control pressure is basically regulated by a restriction, and what this is called a control pressure regulator, also known as a warm-up regulator. That is more or less a variable restriction. It's got a bimetallic strip in there run by this electrical connector that basically will open and close that restriction and increase or decrease that orifice equivalence, and as well as you have some load functions through a couple of different vacuum lines that will also, based on engine vacuum and transmitting load through engine vacuum, change the control pressure as well. The way any differential pressure regulator works is one side's pushing against the other and affecting the other, and that's how you get the regulation. If you think about it, imagine you've got a buddy carrying a backpack full of rocks standing on your garden hose. If you were to put more rocks in his backpack and weigh him down more, he's going to close off your garden hose and basically restrict flow more. Your garden hose is what's feeding your injectors. If your buddy has more rocks in his backpack, i.e. control pressure is higher and there's more pressure down on that garden hose, you're going to get less fuel and less flow to your injectors. If control pressure is lower, then basically that hose is going to be able to push back and maybe lift him up a little bit and allow more flow. So you want to make sure that your control pressure is, in a cold situation where you're kind of running in, say, equivalent of open loop, a default rich scenario, so the engine runs good and can warm up without any performance issues. You want to make sure that control pressure is lower. As it heats up, that warm-up regulator is going to restrict a little bit less and actually decrease your control pressure, increase your control pressure and start to lean that out so you get more into a controlled warm engine range where you're ready for feedback regulation through the computer and the lambda sensor or oxygen sensor. So, let me set up here. Aside from that, you can see that we've got our fuel pressure gauge. We can close this valve and check system pressure anytime we want. We're monitoring control pressure, which right now our pump is not running. Typically, we're going to see somewhere between 35 and 42 for this particular system. And you got to have a good high-quality pump. We're just running, an off-the-shelf pump that's going to put out somewhere between, say, 72 to 85 psi. We want to make sure that we check that to book and make sure that we're getting the right amount of pressure. If our system pressure, what our pump is putting out and what our fuel distributor is regulating, is that we're measuring with this valve closed, is not up to snuff, we want to look at restrictions, clogs, or gum ups in this system pressure regulator right here. Basically, the way that regulator is going to change or be adjustable with pressure is going to be the adding or subtracting of shim washers behind a spring stack inside there. And make sure you consult the manual and do that in a way that you're never dropping any parts and ensuring that all the O-rings are there and that everything comes out clean and goes back in. There's a small piston in this bore with this system pressure regulator. You want to make sure it doesn't bind up. It is married. It is a permanent fixture to this fuel distributor. It's not a replaceable or serviceable item. So if you scratch it, you damage that bore, you're going to be looking at either replacing the fuel distributor or going through a kind of difficult reconditioning process. So I'll set up here and we'll resume the video here in a moment.